Hi and welcome to Boyle's Law, pressure and volume of gas at constant temperature. Now, in this particular lab, we're going to look at the relationship between pressure and volume using a pressure sensor right here. Now this is a quick release coupling, and this right here is a syringe that will fill up with a volume of air. This hooks onto the end of the syringe. This is your tubing. The tubing hooks to this, and the quick release hooks to this, which is then attached to our data acquisition sensor. In the next video, I'll show you how the lab is set up, and also I'll do a sample run. So this is the experiment setup. As you can see, the syringe here connects through the line or through the tube to a quick release connector, which connects to the end of your pressure sensor. The pressure sensor then connects to your data acquisition unit. Now, once you've connected this thing up, you want to check to make sure that you have a tight seal so you can accurately look at the relationship between pressure and volume. So what you do is you start by unhooking the couple and pulling this out to 20 milliliters. Now, what you'll do then is you'll compress from 20 to 10 and check how difficult it is to compress it. If it compresses very easily, like this one is, as you can see, it pushes back on it. If it compresses very easily with no issue, that means that you have a leak. Now, next, what you'll do is you'll unhook your release right here. You'll pull out 20 milliliters of air, okay? And then in 2 milliliter increments, you're going to start at 20, and you'll look at the pressure reading on your data acquisition unit. Then you'll go to 18, taking care to slowly compress it. If you quickly compress it, what happens is it causes the air to heat up, which increases the pressure on the inside. Next, what you're going to want to do is to go from 18 to 16, then from 16 to 14, from 14 to 12, from 12 to 10, and then from 10 to 8. Now, at each step, you'll have a pressure, and from that, you'll be able to calculate the relationship between pressure and volume. Now, while you're compressing, you'll notice that I held this like this. That's actually bad form because I have the phone in one hand to sort of give you guys an idea of how this looks close up. What you want to do is you want to hold it out here on the end so you don't have heat transfer between your hand and the gas on the inside. Hi, and welcome to the theory section for Boyle's Law, pressure and volume of a gas at constant temperature. Now, Boyle's Law is a natural consequence of treating a gas like an ideal gas. If you remember the equation for an ideal gas, and we'll use the chemistry version, PV is equal to N times R times T. Now, in this lab, we're holding temperature constant, which, if you remember, is called an isothermal situation. The number of moles is also held constant as well. So in this particular situation, the right-hand side of the equation is constant. Now, what that means is that there is an inverse relationship between the pressure and the volume. So, if I were to call nRT a constant, we'll say K, and solve for pressure like this, I would have the following equation. Now here, as you can see, as you increase V, as this gets bigger, you would naturally expect your pressure to get smaller in order to make the equality stand. But in this particular experiment, you're starting off with about 20 milliliters of air, and then you're compressing it by approximately 2 milliliter increments down to around 8 milliliters. So in this case, what's happening is that your volume is decreasing and your pressure as a consequence is increasing. So were you to plot that, you would end up seeing something that looks a little bit like this. So this is the inverse relationship between P and V. So just some caveats in this lab to explain why things are done the way that they are. In the experiment video and also in the experiment itself, it's made a point that you want to keep your hand off the syringe as you take and you pressurize it. The reason is because if you remember our conversation about chapter 1 in thermodynamics, if you think about your syringe here, your syringe, when you have trapped the air on the inside, you can treat the syringe itself on the inside as a closed system. So this is a closed system right here. So if you keep your hand over here as you pressurize it, and your hand not directly in contact with the plastic of the syringe, what you're trying to do is you're trying to prevent heat flow. So you don't want flow of heat in here. What that would do would be to cause the pressure to go up as a consequence of the temperature going up. And you're not in an isothermal situation anymore. Likewise, it's also made clear that as you compress it, you want to slowly take steps. So these are the incremental steps that your book mentions. And the reason why you want to take these incremental steps is that you want to give the gas a chance to cool back down to its original temperature as you pressurize it. If you rapidly pressurize something, what that does typically is to cause the temperature to increase unless your substance is in contact with an environment that has a lot of heat. So you want to avoid that. Okay? So, that said, this is the theory section for the lab, and I'll see you in the experiment.